In these types of problems, we are asked to find points of discontinuity and to identify the behavior of the function on the left and on the right from that point. I think that the points of discontinuity, which means where function is not continuous, will happen when the denominator is 0. Thus, x squared is 1. Let's solve for x. X gives me what? 1. Is that correct? No, please don't forget plus and minus 1. Good job for pointing this out. So I have 2 points here which I want to look at because those 2 points give me division by 0 and the numerator is not 0 at those points. So I also was told that if I have more than 1 point, I need to sort them from smallest to largest. That is not usually necessary, but the program wants to grade those types of answers correctly. So let me sort them as -1 goes first and 1 goes second. We are asked to figure out what is happening on the left of -1 and on the right of -1. Let me try to sketch the graph for you. It's not really a graph, it's how I see the situation, and I like to teach it this way. So I have 2 points of discontinuity. Let's put -1 and 1. And I'm first going to look at the left limit. The left limit is the limit as x approaches -1 from the left. Did you see this little negative sign on top of -1? It doesn't mean the -1 is negative. It means we're approaching the function like so from the left. From the left. Remember, in English it sounds really well, from. So you won't be confusing it as to the left. It also means that the inputs here will be less than whatever number we're approaching from the left. Thus, x will be less than -1. Well, let's look at the function we're working with. We are working with x squared plus 1 over 1 minus x squared. Let's simplify that. It will be a limit. X approaches -1 from the left. X squared plus 1. How do I want to simplify? I will write down 1 minus x squared as 1 minus x times 1 plus x. Please remember this formula. It will be showing up so often that you better just learn it once. A minus b times a plus b equals to a squared minus b squared. That's called squared, difference of squares formula. I'm kind of curious what is happening at -1. Well, if I substitute -1 into the first factor, 1 minus -1 gives me 2 because it's 1 plus 1. So this factor doesn't really do anything. But the second one makes 0 in the denominator. 1 minus 1 is 0. I'm just curious, how do I approach division by 0 in this case? With a negative or positive relationship of the original function? Well, if I approach x, which is -1, from the left, that means I'm substituting numbers that are less than -1, which is -1.1, -1.1, let's say 0.1, -1.001. So they're very close to -1, but smaller than that. So what happens to the 1 when it is subtracted by something that is smaller than 1? I don't need the exact answer. I just need a sign. It is indeed negative. So when we approach x, which is -1, from the left, so that is my left limit, or from the left, the 0 in denominator is negative. We get negative results there. Dividing by 0 gives us infinity. So I know that the answer here will be infinity. What I wanted to know is the sign of that infinity. And now I know that the sign will be negative because we have division by 0 and it's a number divided by 0, which we actually can calculate. -1 squared is 1. 1 plus 1 is 2. So it's 2 over 0, which goes to infinity. I just want to know if it goes to plus or minus infinity. And because the denominator is negative, since the inputs are less then -1, right? Then the answer will be -infinity, which means the function is going downhill, down forever. That was like a very slow explanation of how to answer this first question. So maybe I should a little bit faster for the right limit, or not, you let me know. So let me write down a definition of the limit from the right. Let me put it in blue again. Limit from the right as x approaches -1, but now it is plus. Plus doesn't mean positive, it means from the right, of x squared plus 1, and I'll write down 1 minus x and 1 plus x right away. That means that now I am approaching, let me change the color, -1 from the right. From the right, it means inputs are bigger than -1. Very close to them, but bigger. So instead of choosing something like -1.1, what should I choose? I should choose something like what? Exactly 0.9, or I mean negative 0.99, and so on. Very close to -1, but bigger, because we're approaching it from the right. Well, the problem is, again, happens with 1 plus x when x is -1. So I know it's going to be a number, and the number is the same, by the way, too. I know it's going to be division by 0. But what kind of 0? So I even know it's going to be infinity. I can already put it here. Now, 1 adds up to the negative 0.9 or 999 or 9999 and so on. And that is a positive result. So the answer will be plus infinity, which means the function is going up forever. Plus infinity. Or you can just type infinity. Oh, very good. We just finished one point. Let me show you how to work with the second point. Point 2. Point 2 is c equals to 1. Left limit, or limit from the left, will be, let me put it in blue again. Limit as x approaches 1 from the right, f of x, and f of x is still the same, and I will write it down as 1 minus x and 1 plus x, like so. Now I'm looking at the same sketch I have here, and I understand that we're switching to work with the next point, not -1 but 1. I'm approaching 1 from the left. Thus, x will be close to 1 but less than 1. What kind of numbers should I choose to work with this limit? Like 0.9, but positive in this case. So now the troublemaker is the first factor. 1 minus 1 gives me division by 0. So again, I know that we will have a number which is again 2 over 0, which is infinity. I just want to know the sign of it. So not only can I already answer infinity for both cases, but I just need to figure out the sign of each. So when I work with the right limit, actually I don't know why I started with the right limit, and the first was asked to do left limit. Oh, so maybe I should. Let me change that to minus. Left limit. So we answered the first question for point 1. Now, I will choose x that is close to 1 but smaller than 1, so like 99999. 1 minus 9999, getting closer to 0 but positively. So this infinity will be positive, or you can just write just infinity. You don't need to put plus here at all. That means here the function goes up, up, up forever. Finally, the last side limit will be 1 plus. That means we're approaching x in this function from the right. What does it mean to approach the function from the right? That will be the last part of the sketch. It means the inputs will be greater than 1, but very close to 1. So for example, 1.009, right? Or just 1.1 is also fine. Let's use it in this first factor. when I see what is going to happen with 1 minus 1.0009, well, it is positive. Unlike in the previous case, no, in this case it's negative. Unlike in the previous case, it was positive. So it will be 2 over 0, but in this case, from the negative side of it, so it's going to be minus infinity, which means the function is going down forever. The outputs are going down to the minus infinity. And we put minus infinity here. Those are the final answers. Note, let me take 2 more seconds of your time to tell you that those 2 points, x equals plus or minus 1, are called vertical asymptotes. Vertical asymptotes. I think there's a y here. I don't remember, whatever. I call them VAs exactly for this reason, so when I glitch, I don't mess up the spelling. And the graph will look like so. Here is y-axis and x-axis. And I have a function which I don't have to know how it looks, but I know that I have 2 VAs. One is x equals to -1, and one is x equals to +1. On the left of -1, and on the left means here, smaller than -1, the function was going where? Up or down? Down. So the function, whatever it looks like, goes down. On the right of it, it changed its mind, and now it's going up. On the right of -1. So now it's going up. Now, what happens with the other 2 cases? On the left from 1, it's going up, and then it changes in direction, it's going down. So on the left of 1, it goes up, and now it goes down. That's not how it should be. It goes down after this, and it's just a sketch. This is how we work with functions, and we're going to learn more properties of the functions like this, including its concavity, inflection points, increasing and decreasing intervals, and why limits are so important. Thank you for your patience, and keep working hard.